So here's the OpenConnect library, which gives me access to the Connect class, which allows me to use a Connect camera with the processing IDE or processing suite. As we go down, we see there are some minimum thresholds which all have float values. Now these floats are essentially millimeter readings based in the Connect class. So if you divide these by 10, you actually work out what their centimeter measurements are. Now, to actually create an image on the screen, we have to use a pImage class. So at the moment, it is set to none. However, as we go down and we go past the actual setup of a serial port, which I'll come back to, we then go into the setup function. We create a rendering image, which is of size XY, which is 640 by 480. This is not a three-dimensional image, it's a two-dimensional render. However, as we create the Connect class and we use the init depth function, we are able to get depth readings for each pixel which is displayed on the screen. So as we come to image, we initiate it to create image, where we look at the width and height of the Connect camera image, and we also want the image to be in color, hence we have red, green and blue. Now there's one point to make. When you actually collect a depth image, it will not be in colour, it will usually be in black and white. We can then print the Connect width and height so we can find out what the actual values are. And it's these values which we use to set up the actual window. Within the draw function, we set the background to 0. We must always do this because we are going to refresh the background with the image by loading the pixels. The load pixels function gives us access to the pixel information and is the beginning or foundation of updating the pixels. So we've loaded the pixels. We collect a depth by accessing the functionality of the get raw depth from the Connect API or the OpenConnect API. Here I've created 3 data variables, and these data variables are placed inside of the data to Arduino, because this is data which will be sent to the serial line which the Arduino will read. So we create a for loop, which is an order n squared. So we create an offset. Basically you have an x and y position, and if we times that by the width of the screen, we can turn a two-dimensional array into one long thin array of indexes and pixel information. Here we use the minimum thresholds, medium threshold and maximum threshold to isolate distances from the camera and to actually generate colours for those pixels. In this way, the Connect camera can be used as a sensor detection system in the respect of sensing objects as they get within distances. Within each distance, we update the data variable which is in the data being sent to the Connect, and we can generate size information for each object which is within these thresholds. Now, to check which serial ports are available, we simply do a print array and we do serial.list. Then we actually assign a port. Here I've assigned port 0. Using the serial speed of 9,600 bits per second, I had to create a string because I had to cast this integer data to a string. We then write the string to the serial port, and we then write a comma, because on the other side of the Arduino we are going to do a serial.parse, and this will allow us to separate all the data which has come in as one string into separate chunks, which can then be processed and played with. We then update the pixels, so this actually takes the pixel information which has been worked with and it updates it to the screen. That's why you can see the colour information being changed. and we apply the image to the screen.